Hi again. In this session I will introduce you to the basic of spectral feature of objects for image interpretation. Interpretation of remote sensing imagery depends on understanding of electromagnetic radiation and its interaction with surface and atmosphere. The sensors collect images of Earth in different wavelength range in order to better discriminate the features of object on the surface. Knowledge of the subject of our interpretation is the essence of the interpretation. Knowledge of remote sensing theory is also essential for high-quality image interpretation. The interpreter needs to understand how each image is formed and how each sensor displays landscape feature. Different sensors use different parts of the electromagnetic spectrum, different resolution, and use different methods of capturing images. The image interpreter needs to know how each of these variables influence the image to be interpreted and how to derive useful information from the imagery. The interpreter also needs to be aware of contextual information about phenomena, things explored in images. The total incident energy will interact with the surface in one or more of these four ways: transmission, reflection, scattering, or absorption. The picture on the right side of the slide shows the theoretical physical definitions of these phenomena. Their intensity and strength depend on the surface and materials of the objects. Reflection is the phenomena where light or other electromagnetic waves bounce off an opaque surface and change direction. The nature of the reflection depends on whether it occurs on a smooth or rough surface in relation to the wavelength of the considered radiation. Regular or spectrular reflection is when light waves bounce off a smooth surface, such as still body of water or flat asphalt surface. Diffuse reflection is when light waves bounce off a rough or bumpy surface, such as vegetation, and scattered in different directions. Therefore, by measuring the energy reflected or emitted by different objects on the Earth's surface, over a series of different wavelengths, a spectral response is created for each object. When spectral responses are defined for all objects, they can be distinguished by comparing them. This process is used in classification. The spectral response is quite variable, even for the same object, and can also vary with time, for example, vegetation and location. On this slide, you can see examples of regular and diffuse reflection. Regular occurs when photons hit the flat surface of the road, top left, and diffuse when they hit a rough surface like a treetop, top right. The slide also shows the dependence of reflection on wavelengths from water, lower left, and vegetation, lower right. Longer wavelength visible red, near infrared, and middle red radiation is absorbed by water. That shorter visible wavelength blue and green. The blue part of the spectrum is most strongly refracted from the water, then green, then red, and last infrared. Thus, water typically looks blue or blue-green due to stronger reflectance at these shorter wavelengths, and darker if viewed at red or near-infrared wavelength. If there is suspended sediment present in the upper layers of the water body, then this would allow better reflection and brighter appearance of the water. With vegetation, the matter is different as far as the infrared spectrum is concerned. The reflection is strongest in the infrared spectrum, then in green, and weakest in the blue and red. When the leaves wither, the reflection of all parts of the spectrum is equalized. This happens because a chemical compound in leaves, called chlorophyll, strongly absorbed radiation in the red and blue wavelength, but reflect green wavelength. It uses red and blue radiation to carry out photosynthesis and produce oxygen. Leaves appear, for human eye, because we cannot see infrared part of the spectrum, greenest when the chlorophyll content is highest. The internal structure of HELT leaves act as excellent diffuse reflector of near-infrared wavelength. When is less chlorophyll in the leaves in autumn, the leaves appear red or yellow. These facts enable experts in remote sensing to observe and determine the state and health of vegetation based on spectral response. Let's see how different vegetation looks on a color infrared image. Green, red and infrared channels are combined into a color image. The internal structure of healthy leaves acts as excellent diffuse reflector of near-infrared wavelength. In fact, measuring and monitoring the near-infrared reflectance is one way that scientists can determine how healthy or unhealthy vegetation may be. The brighter red, rosy, the vegetation is, the more chlorophyll is had, and then more oxygen it releases into the environment. The darker the red, the less chlorophyll there is and the less oxygen is released into the environment. The specificity of radar imaging is oblique imaging. The impulse is not transmitter perpendicular to the direction of the flight, but oblique to the one side. Because of this, smooth surface act as so-called mirror reflector in the sense that direction of the reflected pulse is directed in the opposite direction from the antenna of device. As a result, they appear dark to black in the radar image data. In contrast, rough surface act as diffuse reflector in that they scatter the incident energy in all directions, including back toward to the sensor platforms. You can see semantic representation of the method of returning the radar pulse and examples of the appearance of individual source of the left part of the slide, individual surface. And on the right part of the slide, you can see how these objects look on the radar image. As for thermal image, we have already seen that they are created in different way that images created by reflected spectrum energy. They are created by emitted energy, radiation of heat, that objects have previously accumulated. They are interpreted in such a way that a warmer object appear brightness and colder appear darker on the thermal images. In doing so, one should know physical quantities such as the thermal capacity or object and their emissivity coefficient. The thermal capacity of an object is the object's ability to store energy or heat. The emissivity coefficient is the ratio of emitted and received energy, and it depends on the material from which the object is built. And that would be all for this presentation. Thank you for attention and see you in the next presentation. Bye.